amazing students. This is Mrs. A, and I love math. Tonight, we're looking at 54, Part A, which is the substitution axiom. And we've already been doing something like finding the value of an expression. Here we have an expression, and when we plug in x is 2, y is 4, and p is -1, then this expression has a certain value. If I change these values, then this expression will have a different value. So x squared would be 2 squared, so that would be 4 times y is 4, so 4 times 4 over p is -1, so 16 divided by -1 is -16. So this expression has the value of -16 when x is 2 and y is 4 and p is -1. Now we've been doing that for a long time. So now the book is wanting to give you a more formal definition of the substitution axiom, because that's what we're using here. We're substituting a 2 for the x, and we're substituting a 4 for the y, and we're substituting a -1 for the p. So now, the first part of this section, we are giving a more formal idea of what substitution means. So, basically, if a is equal to b, then A may replace B, or vice versa. The little VV means vice versa, which means B may replace A without changing the value of the expression, without changing the truth or the falsehood of the expression, and without changing the solution set. So that is a pretty good, concise definition of the substitution axiom. Okay, so let's say it one more time. If A equals B, then A may replace B, or B may replace A, without changing the value of the expression, without changing the truth or the falsehood of the expression, and without changing the solution set. So that's what the first part of this section is all about, and now we're going to use it. Okay, so now we're going to talk about 54 Part B, and we're talking about simultaneous equations. And this is kind of getting us used to what simultaneous equations are. And I'm going to go into something that the book doesn't go into till later, because I think it will help you to see what's going on. Okay, this is the equation of a line in standard form. This is the equation of a line in not one of our major forms, but it's still a line, because if I brought the 3y over this way, then it would be close to standard form. So they're both lines. Now there's only so many ways that we could situate two lines on the same graph. Okay, if we had two lines on the same graph, either the two lines, so here's a graph. I'm going to erase the graph so we don't get confused. The two lines could cross, okay? The two lines could be parallel. There's only one other situation. The two lines could actually be the same line, okay? Now, this is what we're usually looking for. When we're trying to solve a simultaneous system of equations, we're looking for the point where two lines cross. Okay, so with that picture in your head, I want you to look at what they're saying up here. They're saying that 3, 5 makes this equation true. So if I plug in a 3 here, I get 6 minus 5 is 1. That's true. Okay, now there's an infinite number of solutions to that line, an infinite number of points that will make it true. Over here, 5, 2 solves this line, because if I put a 5 right here, put a 2 here, we get a -6 plus 11 is 5. So yes, 5, 2 is a solution of this line. But there's an infinite number of solutions to that line. Okay, every point on the line is a solution to the line. However, neither one of these points is the place where the two lines actually cross each other. Wouldn't you agree that that point right there has to be a solution of both lines? and therefore it is the solution of the simultaneous set of equations. So now when we are wanting to say in notation form that we want to solve for the one point that makes these two equations true, we're looking for the solution to the set of simultaneous equations. We put a parenthesis mark right here, okay, and we show this. It doesn't have to have another closed parenthesis. This is a special notation for a system of equations. In other words, I'm trying to find one xy value that will make this one true and this one true. And the way that we're going to go about solving that is using substitution. Okay, so here we go. We have our system of equations. Now we're going to use substitution, which means that we're going to substitute one equation into another. Can you see how x is equal to negative 3y plus 11? But I see an x in this equation too. So now I'm going to slide one equation into the other. So 2x, and I'm going to put a parenthesis for that x, and I'm going to include in the parenthesis the meaning of x, which is negative 3y plus 11, and then 2x minus y equals 1. So basically I smooshed two equations together into one equation by taking this as my main equation and this one as my sub-equation. And then 2x, instead of the x, I put parentheses. I slid this definition of x in there. I continued minus y equals 1. So now we can distribute this 2 through here. So negative 6y plus 22 minus y equals 1. Negative 6y minus y is negative 7y. Now I'm going to subtract 22. Subtract 22 is equal to negative 21. Divide by negative 7. Divide by negative 7. Y is equal to 3. Okay, so I'm halfway there. I've not found my point. I've only found the y part of my point. So I'm going to put y equals 3. Okay, so now I've got to find the x that makes both equations true when y is 3. So when everybody see how I did this, now I'm going to, now that I've written y is 3, I'm going to erase all of this so that we can keep our equations on the board. I found out what y is. So now look at this equation. Look at my sub-equation. It says x is negative 3y plus 11. But we just found out that y is 3. So let's take out the y and plug in a 3 because we can substitute. So x is negative 9 plus 11 equals 2. So x is 2. Okay, so now we just used this equation and found that x is 2. So now let's check by substituting 2, 3 into this equation. So x is 2 would go right there, and y is 3 would go right there. And we'd have 2 times 2 is 4, minus 3 is 1, and that's true. And then we already checked to see that these both worked in this one, and that was true. Therefore, 2, 3 is the solution point, and 2, 3, if I graphed both those lines, 2, 3 would be where the two lines crossed. Isn't that cool? Okay, so this is example number 2 of 54, and I have my system of equations. My simultaneous system means I'm supposed to find the point where the two lines cross. Okay, so I'm going to substitute. I'm going to use, since this one is solved for y already, this one's going to be my sub-equation, this one's going to be my main equation. I copy down my main equation, and I'm going to leave a hole or parenthesis where my y is, because my y is what I'm going to slide in. So plus 3y equals negative 13. So I put down my equation. Now I'm going to slide in the y is x minus 6. I'm going to distribute 2x plus 3x minus 18 equals negative 13. 2x plus 3x is 5x minus 18 is equal to negative 13. Add 18 to get the 5x by itself. 5x equals 5. Divide by 5 on both sides, and what do I have? 5x equals 5, that means x equals 1. Okay, so now I'm going to put that answer up here. X equals 1 there. And now I'm going to erase this board, so make sure you've got all of that on there. So I'm going to leave the x is equal to 1, and I'm going to go find out what the y is. That's going to make this true. This is really a lot of fun when you learn how to do it well. It does not take long once you learn how to master the process. Okay, so here we know that x is equal to 1, so I'm just going to substitute the x is equal to 1. Then y is 1 minus 6, or y is negative 5. So I have y is negative 5. So now I just used this one to find y was negative 5. So I really don't need to check it in there again. So I'm just going to check it into this one. So x is 1. So I'm going to substitute a 1. Y is negative 5. So I'm going to substitute a negative 5. 2 minus 15 is negative 13. And it works. So my point is 1, negative 5. And again, that would be the one place where the two lines cross each other. It's the one point that solves both lines. Okay, so this symbolism tells us that we are to solve these simultaneously to find the one point that makes them both true. So here I've got x equals, so this is going to be my sub-equation. This is going to be my main equation. I'm going to write down my main equation, 3x, but I'm going to make the x, since that's my sub, I'm going to make a parenthesis for the x. 3x plus 2y equals 3. I'm going to slide in the x, 3y minus 10. I'm going to distribute 9y minus 30 plus 2y equals 3. I'm going to add the 9y and the 2y together. 11y minus 30 equals 3. I'm going to add a 30 and add a 30. And I'm going to get 11y equals 33. If I divide both sides by 11, I get y equals 3. So y equals 3. So I'm going to go ahead and put that way up at the top over here to save it. Y equals 3. And I'm going to erase all of this. So make sure you have it down on your board if you need it. It's in your book. Okay? And we erase all of that so we have some more room, because we need to go and find the x term. So here we are. Nice clean board. Y is 3. We know that. So we're going to substitute the y in the sub-equation. So x is 3 times 3 minus 10. 9 minus 10 is negative 1. So we have x equals negative 1. Now, we already have checked it in this equation, so we're going to go back up here. X is negative 1. Y is 3. Negative 3 plus 6 is 3. It checks. So our answer is negative 1 comma 3 is our ordered pair solution. All right, so here we are on example 4 now. And we have one equation that has just a y. So this is going to be our sub. This will be our main equation. Copy down your main equation. But we're going to leave a hole where the y is. So we're going to have minus 2 y equals 4. And then where the y spot is, we're going to plug in the negative 3x plus 8. Negative x, distribute the minus 2 all the way through. Negative 2 times negative 3 is positive 6x. Minus 2 times 8 is minus 16 equals 4. We get all of our x's together and we get 5x minus 16 equals 4. Add 16 to both sides. 5x equals 20. If I divide both sides by 5, then I get x equals 4. Okay, so we're going to put up here in a little answer spot, x is equal to 4. Okay, so there's all of that work that I'm about to erase. Okay, and we found our x, and now we need to go and find our y. And it's as simple as finding our sub-equation, taking our x into it. Y is negative 3 times 4 plus 8. Negative 12 plus 8 is negative 4. So y is negative 4. X was 4, so 4 comma negative 4. Now, we already checked this in our sub-equation, but let's go and check it in our main equation up here. So 4 negative 4. 4, negative 4. Let's just check to make sure. Negative times a 4, negative 1 times a 4 is a negative 4, plus 8 is 4, and it checks. So our solution is 4, negative 4. Check. This one's an interesting one. X is equal to y. Okay, so we have our sub-equation because we've got it solved for something. One thing, x is one thing, y. So we've got our main equation here. So we're going to write down, we're going to let this be our variable. We really could pick either one of them, right? We're going to let the x be the variable. So 2 parenthesis plus 3y equals 5. So we're going to, in place of the x, substitute in the y. 2y plus 3y is 5y equals 5. So y must be, divide by 5 on both sides, and y must be 1. But when I substitute that back in, that means x must also be 1. And the point is 1, 1, but we'll still check it in this equation, okay? So 2 times 1 is 2, plus 3 times 1 is 3. 2 plus 3 is 5, and it works. We've arrived at the practice set. So, copy it down, and then I want you to go see if you can do it without me. All right, so copy it down and pause your video. All right, so here we're going to have this one as our sub. This one is our main. We're going to copy down the main equation. 2, this is our sub variable, so we're going to leave a little hole. 2x plus 3y is 24. We're going to substitute instead of the x, we're going to put 4y minus 10. We're going to distribute. 2 times 4 is 8y minus 20 plus 3y equals 24. 8y plus 3y is 11y minus 20 equals 24. So now I'm going to add 20 and add 20 to that side. So 11y, this cancels out. So I need a little bit more space. I'll come up here. 11y. The 20 cancels the 20. Negative 20. 24 plus 20 is 44. So I'm going to divide by 11 and divide by 11, and I get y equals 4. Okay, look at that real carefully because I'm about to erase that so I can do the second part. So we got y equals 4. Okay, so now we're going to erase that so we can do the last little bit. Okay, so now that I have y is equal to 4, I'm going to plug that into my sub-equation. So x equals 4 times 4 minus 10. 16 minus 10 is 6. So x equals 6. Now we've already checked it in this one. So let's go up here and let's check both of these in here. And if it works in there, we know we got the right solution. 2 times x is 2 times 6. 3 times y is 3 times 4. 12 plus 12 is 24. And we found the solution. So the solution point is 6, 4. And we write it as an ordered pair. Just like that. Last practice problem. Okay, so we have a simultaneous system as designated. Okay, now this one on top is the sub-equation because it's the one that's solved for a variable. So that's the sub, and this one is our main. Okay, so we're going to write down the main equation. X plus 2y, since y is the sub, I'm going to leave a spot for y, equals negative 16. We drag down the y here. X plus 7 is going right in there. X plus 2x plus 14 equals negative 16. So now we have x plus 2x is 3x plus 14 equals negative 16 minus 14 minus 14. This cancels. So we end up with 3x is negative 30. Divide by 3, divide by 3. X is negative 10. So x is negative 10. X is negative 10. So we're going to plug it back in here to the sub-equation. Negative 10. Negative 10 plus 7 is negative 3. So y is negative 3. So now let's take both of these and check them into the other equation, which was our main equation. X is negative 10. Y is negative 3. So negative 10 minus 6 is negative 16, and it works. So our point is negative 10, comma, negative 3, ordered pair. There's our answer. Aren't those fun? And that is how you use substitution to solve simultaneous equations. And we are done with lesson 54, and this is Mrs. A. And may God bless your day.